Good morning, good afternoon, good evening. My name is Arthur Kane. I'll be host of today's webinar. Our topic is Power the Digitalization with UX or User Experience Monitoring. Today, my colleague and product owner for Network Performance Monitoring and Diagnostic Product, Lubos Lunte, will be joining. Hi, Lubos. Perfect timing with starting your camera.
Hi, everyone. Thank you, Arthur, for the introduction. My pleasure for being here.
Excellent. It's very nice to see so many of you joining. However, if you miss any part, we will be recording the session and we will share it with you after the webinar in an email follow-up. And without further ado, let's start. We will actually start off with some theory on a few slides, and then we will jump into demo. And there will be plenty of time for questions and answers. If they will be relevant, we will answer them during the presentation. Otherwise, we will have some time at the end of the session. And on that, please do feel free to send any questions or comments. We will be more than happy to answer them all. Today, we will start by explaining challenges that we see our clients are facing in the modern era when trying to make sure their applications are performing well. Among those, it is environments being more and more hybrid and heterogeneous, and also rapid digitalization powered by work from home and the current situation. We will also present different approaches to application and user experience monitoring. We will explain their pros and cons, and we will demonstrate live our products that deliver synthetic testing and network analysis. We'll also explain benefits of combining these technologies, and we will show you some more documents that you can read after the webinar to learn more. To explain the whole reason why we are here today and why Flowmoon focuses on monitoring user experience. Applications are all around us. They are critical to many companies and many businesses, especially in these days when we have to interact with companies virtually. Having this interface of some application is of absolute must and importance. User-centricity is a movement that actually focuses all the features and usability of applications around user and making sure that it's as optimized and streamlined for user to get the best value. But regardless of how UX designers and application developers are successful and experienced in their jobs, if the performance between user accessing the application is not optimized, and if they feel any performance issues, the whole point and the whole experience of the application is immediately ruined. There are statistics that say that over 50% of users of websites that take over 3 seconds to load actually leave. And I believe most of you understand this. When, for instance, you're downloading an application from your marketplace and you are not able to figure out how to use it in a few seconds or maybe minutes, you will go and look for another one. We are looking for best and fastest solution, and we're not patient to wait for someone to load, because it is so much easier to go and look for a competition. The places that we're accessing applications from vary a lot. Or are the days when it was mostly using desktop computers in offices to access some business applications. We more often use our personal devices. We connect from home, we connect from coffee shops in different places where our company and our network departments are not able to guarantee performance of the infrastructure and of the network, and not even able to guarantee performance of our personal devices. So measuring all of these environments and combination of them is much harder than it was before. And we also see that ownership of applications and their delivery is very decentralized. By that we mean SaaS applications, for instance. We are dependent on applications like Microsoft 365, but we don't host them, we don't develop them, and any control is completely out of our hands, and we need to rely on our supplier. And hence, this is another reason why we are losing control gradually over the application experience. We see that problems accessing applications and performance and overall poor technology is a big reason why companies struggle keeping the productivity of their employees while at home. Another big reason is actually motivation and social distancing and troubles that come with that. However, technology is very important. Lubos, because you will be demonstrating Flowmon live, to give an example of what kind of environment we see with our clients and that we usually monitor. Can you comment this slide?
Yeah, sure. It's what we see at our customers that it's been changing during last few years. Obviously, a few years ago, the typical environment, the customer side, looked slightly different. Right now, what we see is typically some headquarter part of the infrastructure, then some branch or even branches, then customers have their employees working from home offices. They use private clouds for some part of their infrastructure, and obviously they also use public cloud services or some SaaS applications. And what is very important nowadays is to keep them visibility to all these parts of their heterogeneous environment, and still remain the single pane of glass view for all of it, because obviously there is plenty of tools for each part of this infrastructure which can be used, but what we see customers often miss is like one single or unified view on these different environments. So this is how I see it has changed, and it also brings some challenges as it's troubleshooting and application troubleshooting always has been a challenge, but having in mind the previous slide and the complexity and raising complexity, it's even harder nowadays. And as you also told us in your introduction, it's also about being responsible for part of infrastructure where you do not have sometimes direct touch or a tapping point or whatever. So it's very challenging right now. But still, it's very important for all of them to be able to do decisions, to do troubleshooting, capacity planning, watch for SLAS, and also to have data for their decisions. So it's still very very big topic for them to get and obtain information from these different parts of environment. And what for? What is the data for? Obviously for being proactive, as we realize that being alerted on some trouble is too late, just too late. If either customers or employees are complaining about some internal or external system not running well, it's just too late. We have to be alerted on decreasing user experience, so administrators or operators have time to address it before it makes some business harm. And what is another challenge is to keep all this machinery as simple as possible, because that there are different technologies, different solutions. Some of them some of them are robust, just agents. Of course, if I have agent on each my endpoint or application server, it's cool that the visibility is there, but still, what is the cost of such robust solution? What is the complexity? What is the need of skills and having someone who is watching for everything? So this has to be somehow weighted. So this is what I see as challenges.
Great, and I think we're ready now to start talking about how to tackle these challenges. Going back to the first point that you had, it is a combination of being able to measure SLAs at all times, being able to measure availability of critical components, which are things that we can quite easily do with tools that are generally available. But then also having the capabilities of troubleshooting and being able to deep dive requires maybe a different set of tools. And so we covered a few use cases. And for those few use cases, we also have a few different solutions. So let's try to describe and show them all. Probably the most common, and Luboš, correct me if I'm wrong, means of monitoring application, not necessarily experience, but availability and status, and whether the application and underlying infrastructure are up and running, is infrastructure monitoring, or infrastructure or availability monitoring, sometimes also called. And this is actually a dashboard from a tool called PRTG by company Passler that we are in technology partnership with. And Luboš, why do we show this specific dashboard, and what do we see here? What does infrastructure monitoring bring?
Yeah, I would like to discuss different approaches for monitoring, and infrastructure monitoring is kind of must-have for infrastructure teams. It's basically something which provides you information you definitely need where if you are a network administrator, as it provides you information about the availability of either network components or network devices, servers, their health. But what you see here is like the components view and their status. Even if you imagine, I don't know, router or switch, you can even check the utilization of their interfaces. So you have like visibility whether everything runs well from the infrastructure side. But we realize that sometimes it's just happened that the device, either router, switch, server, whatever, runs well from its hardware side. It works, but just the application doesn't work, and the customers or the users face problems, right? So what we miss here in such a tool is the user experience view on the application, and but still, I'm not just I'm just not comparing like competitive as a solution. It's kind of complementary. So I'm just discussing the differences. It's very different use case here. So I do not claim that somebody should switch off the infrastructure monitoring. Definitely not. It's a very useful tool, right?
It's definitely a must-have and something that everyone who wants to do monitoring should start with before jumping into some more deep level analysis. And also maybe to expand on what you said, I think great example could be monitoring of, as you mentioned, port or switch interface throughput. While with infrastructure monitoring, we can see that the switch was attempting to send some packets or was receiving some packets on an interface. It doesn't mean that the switch necessarily forwarded them or they went through, or that across some point of the network there were no network losses. So we are able to say that there is a status of some component and that it is healthy. However, we are not able to say the reality of the traffic going through this component, and therefore we're not able to measure real user experience. Again, very complementary to deeper network visibility. Now, in order to be able to debug application and actually see where are problems in the application performing poorly and users having bad experience, is to use agents. And this is a very traditional approach to application monitoring. It is very application oriented, and while we are able to also monitor network latency, these tools were designed for application departments to tackle and understand the behavior of their applications. Boshi, can you explain how does this technology work and again some pros and cons?
Yeah, here in having deployed agents on server, you obtain visibility in different layers. So it provides you really deep visibility for in the application layer. You can even see the level of source code execution, which is really great for deep investigation of the application. But if you would like to catch each transaction, you have to deploy these agents on the overall environments, and I would say it's kind of or for some use cases it could be just overkill to deploy, maintain, and work with all this machinery if the use case is like the measuring of the user experience in terms of the delays of the transaction introduced by the network, application server, database server. And so yes, this technology is very deep, very robust. Also often used for the critical applications, but still it's kind of very like a heavyweight solution.
Mhm. So our recommendation would be if you're an application developer who has some application running in production and wants to troubleshoot performance issues introduced by the application and real traffic with real users, and you want to really go deep down, then this is a great option for you. However, due to how robust the technology is, resources needed, but also the financial side, it's not scalable to monitor all third-party applications that your company uses and really scale across hybrid environment for general everyday monitoring of those things that are paying and maybe impacting our internal employees in their work, but is not necessarily that one application that you own and run as a service for your customers. Next technology is synthetic testing. And here this screenshot is actually from our user interface because synthetic testing is first tool used for application monitoring that we offer. But that's not important for now. Let's talk about how does it work and what's the principle and what is the use case. And to start off with the use case, Luboš, can you explain what is the scenario where to go for synthetic testing, when to use it?
Yeah, synthetic testing is being used for like periodic checking of the availability or measuring of the SLAS. So in fact, you are just replacing real user by some script and doing repetitively some scenario or operation over some particularly HTTP application or database application. So you just want to make sure.
And sorry to jump in, how is it different to infrastructure monitoring? Because we also said that infrastructure monitoring can tell us about the status, uptime, and health of the application. How is this different?
Yeah, here you can, if you imagine, I don't know, for example, some internet banking, you can really act as a user. So you can create a scenario who is like you are creating just a login, filling in the login page, clicking on the login, waiting for the home page of the internet banking, then clicking on your account, balance, whatever. And the scenario is measuring what is the latency of the application, and is watching for your SLAS, and you can see it in time. Even if no customer is, because obviously if you have hundreds of customers during all day, you can just work with the real data. But if not, or if you are watching for some differences from different geographical locations, you can just put some robot or agent or like executor of the script in this location, and you can perform this action repetitively and in the very same way, so you can easily compare all the results from this. So that this can be very useful for like long-term measuring and comparing of the condition of the application.
That's great, and I think it is time to demonstrate the same. Are you ready for presenter rights?
Yes.
There you go. It's yours.
Okay, so this is Flowmon APM transaction generator, which is which is in fact synthetic monitoring. It's not very spread or very known among our customers, as it's not our primary use case, right? We are more focused on the network performance and application performance, and to be honest, like from my side, this is not a rocket science. Having this like synthetic operations, but what is really great to have this information together with the network performance information, with the application performance, and seeing these all information in one context. So here is let's say dashboard of my test or a demonstration use case. We are pinging here flowmon.com website, and we are watching for its availability. So we can see here what is the availability. We are pinging it once per minute, and we can watch in time what's going on. We can see if it was all the scenario was successful, or it has been some failure. We can even see the duration of the scenario. So then we can investigate what happened in the time, and we have this long-term evidence to show you how the scenario looks like. So we are opening the page, waiting for the content. We see in each iteration what time or how long does it take for opening the website. Then we are clicking on our part network behavior analysis, waiting for the content, then clicking some form, and then clicking for the contact page. Here I would like to show you also, like, if the test is ending with the failure. Here we see that there has been a failure in the last step, and we can even see the screenshot how the failure looked like. So it seems that the pictures are not present, and the page was not loaded successfully at the end. So this is how you can easily track, like, synthetically, some kind of application. The technology behind this Selenium scripts, many of you are familiar with that. You can just, as I described, you can imagine this as simulating activity of the user.
Have you just found an error on our web page, or was it expected behavior?
It was not. I do not know the root cause right now, but it's I didn't do the investigation behind it. Just I was, to be honest, I was happy that I had some failures here to show you that screenshot stuff and so on. So, but
I see. I see. I thought this was completely unexpected, and your testing script just found an error that we were not aware of. But that's great that you had this prepared. Thank you. Are we ready to jump back to the presentation?
Yes.
Okay, so that was synthetic testing and live demonstration, and we're going into network analysis. Now, let me hide a few windows here. Good. Network analysis is different approach to measuring application performance and network latency. It's done from the perspective of the network, where we measure communication and traffic between users and applications And by measuring some critical timestamps in that conversation, we're able to measure the difference between application and network delay. There are actually two ways how this can be implemented. One is more general, that can be applied to any web application, regardless of whether you own it and run it and deliver it or not. And one more deeper, that goes into the level of actual user transactions and clicks that you use for your critical applications that you own and want to troubleshoot more deeply. Lubos will show live demonstration as well in a second, but before you jump in there, can you tell us what are the main differences between network analysis and agents, and what are some pros and cons?
Yeah, definitely. The main pro or advantage of the network analysis is that you do not need to access endpoints. You just have the data from the network, and you measure, and you are able to catch each transaction, no matter what was the endpoint or the endpoint device. So you just tap the network, and you are done. So this is very big advantage, that you can have each transaction for each user for the long term.
And in terms of so that was, that it is unintrusive, it's passive, it's easy to deploy. But what about the level of detail we're able to see here? Are you going to cover this in the demo? If yes, then we don't need to spend time on this, and we can jump right into the demo.
Yeah, let's jump into demo, and I will show you the level of detail you can get from the network data. So please give me the presenter back.
Sure. It is yours. Let's see if you're sharing the screen. There we go. And can you maybe zoom in just a little bit in those views where there are tables with small text, just make sure that everyone can see it.
Sorry, I didn't get all your sentence.
Sure, if you could zoom in just a little bit.
Okay.
Thank you.
Okay, I will try. Oh, maybe this. Me. No. Here.
Yeah, that's great.
Okay, cool. So let's start at the dashboard, where we combine informations from the traditional network monitoring, putting together net flow data together with the NPM statistics, such as round trip time, response time, retransmissions, but also the application performance data, watching for the HTTP or HTTPS or SQL applications. And here we can see the statuses. So here we can see the application performance, some overview of specific applications. Here is for the demo, some eShop, SQL database. We can watch for retransmissions. The differences here is that the data is somewhere it's just the network data, which you are able to catch from the overall communication. So you do not need to access not access, but to be close to the application server. And then we have application performance monitoring, a specific measurement for some applications you are running. And so you can put probe near to the application server and do the measurements. And I will just go for the details. You can see for such application performance measurement from the network data. And here, let's see the dashboard for the MySQL database, where you can see so-called APM index, which is just the number. If it is close to 100, that means that almost 100, or in this case, 96% of transactions meet the SLA. And if not, you can just check in the dashboard what's going on. Here you can see 5 slowest transactions. You can go and I will show you in a minute the details of some slower transaction, but I would like to show you also the spread of the application response time. Then you can just see all the transactions, and I would like to show you here even the error codes. So you can track the transactions with error code, then you can do the filtering of those transactions. And if I remember correctly, this 1064 means the error code in MySQL means that there is some wrong syntax. So you can just, from the network data, you can check that there is some syntax trouble. But let's see here if I can imagine the workflow. You see that it's not 100. So what's going on here? Let's check some slow transaction. You can show the details of the transaction. You can see some average values, median. Then you can go for even for the details of each transaction, show the SQL query, and you can do like really deep investigation here. Maybe going back here. Yeah, I shown you the response in the previous click. So here is great stuff from my perspective that you can really do the checking of the SQL query, which is being executed so long. You can check if there is some unoptimality and see it like from this context. I think, yeah, this is it from the workflow. Maybe we can just jump back into presentation. We have some principle slide with principle prepared, so maybe we can spend some time on that. Yeah. Okay. So let's take a look how it works. In fact, to be able to measure this application data, such as request transport time, application delay, or response transport time, you need to place a probe close to the application server, and then you can get not only this information, but even if the server calls the SQL database, you can see then also the delay or the latency introduced by the database. So then you can like you can distinguish the latency introduced by the network, by the application server, by the database server, and it's very good for troubleshooting. If you can jump into the problem, you immediately know if the problem is the network, application, database, and if in the application you know which part, if it was internet banking, you know if it is about if it is the part of the application which provides you the new payments or some reports or whatever, so you immediately know what to do.
Thank you, Bush, for the demonstration. I managed to answer some of the questions that we had over the chat. I actually also asked one of our pre-sales engineers to answer one of them, but there was one that I wanted you to cover here. What about applying network monitoring to cloud applications? How does that work? And can you be very brief, please?
Yes, we do support the native options of the public cloud environments. We are able to cover this application performance monitoring in the very same way as in the on-prem environment. That means you have to mirror the traffic from the application server hosted in the public cloud, and it works just same as in on-prem environment. So as I shown you.
Wonderful. And can you tell us what are the specific errors or problems that we're able to tackle with network monitoring?
You refer to error codes right now?
Yeah, describe this slide.
Yeah. Okay. It's definitely you, thanks to the network-based application performance monitoring, you can track the user experience. You can watch which transactions were slow. You can watch for context of or patterns if some users from some specific location have troubles, or if some specific part of the application is slower than other. You can distinguish instantly whether the trouble is on the network or application, and avoid the very standard situation in the support area, whether the trouble is on the network or application, and pointing out from one department to another. Definitely you can handle the error codes. So as you can imagine, the error codes in HTTP, HTTPS communication, MySQL, you can watch whether there is some increased number of error codes which could prevent you from some bigger trouble in the future. So this is definitely the main points. But of course, it has some consequences, and having this kind of monitoring running, you can avoid of confusion of your employees, customers, and you can solve the troubles before they are reported by the customers or users. So this is the main use case what I see here.
Thank you. So to summarize, if you want to measure your application performance and user experience of those applications, a great measure and a great start is infrastructure monitoring. Infrastructure monitoring will tell you application infrastructure status, health, and availability. It will not necessarily tell you the actual user experience. If you will have a critical application that you deliver as a service to your customers and your business is dependent on it, a great measure would be to use technology that leverages agents that is capable of helping you to debug code level problems. When you want to make sure that across whole hybrid infrastructure, all applications that you either own or just use as a service are performing well, your internal employees are productive and can do their job as expected and your customers are happy, use combination of synthetic testing and network traffic analysis. Synthetic testing helps to monitor SLAs and availability and response of application even in off-peak times when there are no real users. And when there are real users, network traffic monitoring will completely passively measure their user experience per every transaction and tell you where exactly the problem is. With that, you're able to have much better productivity of your employees. You're able to avoid customers being unhappy with your services. You can minimize the impact of performance degradation on your business. And specifically with Flowmon, there is a very fast time to value, given how easy the technology is to deploy and how unobtrusive it is, and the fact that you don't have to install any agents. And finally, take control of decentralized ownership and have some evidence and proof that your suppliers are not delivering their services as expected or according to SLAs. Here are some documents that we strongly encourage you to read. We will send the links to them in a follow-up email where we will also share recording of today's session. And since we are running out of time and I had some time to answer questions during your presentation, and you also helped me with some related to cloud, there's actually one more standing, and that was whether we're able to get data from Flowmon APM to Fastler PRTG. As of today, we are not, but stay tuned. We have more development planned with this integration. Thank you all very much for your time. It was our pleasure. Thank you so much, Luboš, for your time as well.
Thank you very much, Arthur.
Stay tuned for the next webinar, which is called Tackling Networking Issues Between Users and Cloud Apps, where we have a special guest, a product manager for cloud networking at Google, who will be showing us and telling us more about the cloud part of ensuring user experience and performance. Thank you very much again for your time. Stay well and talk to you soon.